Good morning students. Today I will discuss about a design of sedimentation tank with a problem. Please come to the topic. So first of all put on a heading that design of sedimentation tank. So what is the design of sedimentation tank? That means we have to design a sedimentation tank with some data. So please write down a problem. The maximum daily demand of a water purification plant. So this is the question. The maximum daily demand of a water purification plant has been estimated as 12 million liter per day. Has been estimated as 12 million liter per day. So this is the maximum daily demand of a water purification plant. Now design the dimensions of a suitable sedimentation tank. Please write down. Design the dimensions of a suitable sedimentation tank which is actually fitted with mechanical sludge removal arrangements which is actually fitted with a mechanical sludge removal arrangements for the raw supplies, assuming a detention period of for the raw supplies, assuming a detention period of 6 hours and the velocity of flow is 20 centimeter per minute. And the velocity of flow is 20 centimeter per minute. So this is the actual problem or actual data by which we have to design a sedimentation tank. So what are the given data here actually? The important given data is that is 12 million liter per day is the maximum daily demand. It is very much important. It is the main factor for design of sedimentation tank. Another main data, that is the detention period of the sedimentation tank, which is actually 6 hours, and there is also a mechanical sludge removal arrangements in this sedimentation tank. And the last one is the velocity of flow in the sedimentation tank is 20 centimeter per minute. So these are actually given data for this problem. So let us solve the problem. So this is the answer. What are the given data here? The given data are, first one is maximum daily demand, that is 12 million liter per day, which we can write down as 12 MLD. And another data, that is detention period. The detention period, suppose this is 1 and this is 2, detention period is also given, that is 6 hours. That means it will take 6 hours time to flow from one end to another end. And the velocity of flow, that is 20 centimeter per minute. So velocity of flow, that is 20 centimeter per minute. So first of all, we have to convert this maximum daily demand in liter per day, because here all the calculations is in liter per day, or more rather than meter cube, because here the velocity is 20 centimeter per minute. So first of all, we have to convert it. So please write down the quantity of water to be treated during 6 hours detention period is 12 MLD. That means 12 million liter per day. So if here we write down that per day, then this will be 12 million liter, which we can write down 12 into 10 to the power 6 liter. This is per day. Now per hour, what will be the value? In the detention period, the value should be, as here detention period is 6 hours, so we can write down that the quantity of water to be treated during the 6 hours, that is by 24 into 6. Here by 24 into 6, and the unit will be liter. Okay. So if we simplify this, this is actually 3 into 10 to the power 6 liter. So quantity of water to be treated during the 6 hours detention period, that is 3 into 10 to the power 6 liter. Now if we convert it into meter cube, then it will be multiplied by 10 to the power minus 3. So we can write down 3 into 10 to the power 3 meter cube. So this is the amount of water is to be treated. So we can conclude that what will be the capacity of the sedimentation tank? The capacity of the sedimentation tank should be 3 into 10 to the power 3, that means 3000 meter cube. So we can conclude that the capacity of the sedimentation tank, that is 3 into 10 cube meter cube, that is equals to 3000 meter cube. So this is an important one, that is the capacity of the sedimentation tank, which we have already calculated, that is 3000 meter cube. Now we have to consider the velocity of flow. So what is the velocity of flow? So the velocity of flow to be maintained, that is 20 centimeter per minute. So we can write down 0.2 meter per minute. This is the velocity of flow to be maintained. Now our next part is we have to calculate the length of the tank. So please write down the length of the tank required is velocity of flow into detention time. This is from geometry. So the length of the tank, that is equals to velocity of flow into detention time. So what is the velocity of flow? Velocity of flow is 0.2 meter per minute and the detention time is 6 hours. So this is 0.2 into detention time is 6 hours. So we will convert it into minute. So we will get the value in meter. And if we calculate this, then you will get, that is 72 meter is the length of the tank. Now we have to calculate also the cross-sectional area of the tank. Here actually meter per minute into minute, then this unit is meter. Now we have to calculate the cross-sectional area of the tank. So please write down the cross-sectional area of the tank, that should be the capacity of the tank by length of the tank. That is, should be the capacity of the tank, as it is a rectangular tank, by the length of the tank. Here the unit of capacity of the tank is meter cube and the length of the tank is meter. Then what will be the unit? Unit should be in meter square. So put the value in this equation, and the capacity of the tank, that means 3000 meter cube, and the length of the tank, that means 72 meter. So this is the actual equation of cross-sectional area of the tank. Now if we calculate this by calculator, you will get this value is 41.67 meter square. So this is 41.67 meter square. Approximately we can write that 41.7 meter square. This is the cross-sectional area of the tank, and our main aim is to calculate the dimension of the tank. That means the length into width into height. So height means depth. So here the width and depth both are almost unknown. So we can assume the depth of water in the tank. Okay. So if we assume the depth of water in the tank, then we can easily calculate from the cross section area the width. So please write down, assuming the depth of water in the tank is 4 meter. Then what will be the width of the tank? So width of the tank should be 41.7 by 4 meter. So if we calculate this, we will get 10.42 meter, which is almost equals to 10.5 meter. So this is the depth of the water is 4 meter, and the width of the tank, that is 10.42 meter, which we can write down almost equals to 10.5 meter. So here the three dimensions, that is length into width into depth, which we have already calculated, and here the depth value is assumed. Now there is a concept of freeboard. Do you know what is freeboard? Freeboard is the opening that is kept in the tank for an emergency purpose. It may be for aeration, it may be for overflowing. There are different purposes of providing freeboard. So this freeboard, there is a calculation of freeboard, or there is a formula of freeboard which you will get in your any portion or MTech portion, but here as a lump sum cases we actually assume the freeboard as 0.5 meter for the sedimentation tank. So we have to assume a freeboard. So assuming, please write down, assuming the freeboard of the sedimentation tank assuming the freeboard of the sedimentation tank, that is 0.5 meter, we can write down overall depth of sedimentation tank, overall depth of the sedimentation tank, that is 4 plus 0.5 meter, that is 4.5 meter. So overall depth of the sedimentation tank is 4.5 meter. So it is a rectangular sedimentation tank. So we can easily conclude that the overall dimension of the sedimentation tank. So please write down, hence provide a sedimentation tank of overall dimension of 72 meter into 10.5 meter into 4.5 meter. So this is actually length, this is actually breadth, and this is actually depth. So this is the final statement of the design, that you have to provide a sedimentation tank of 72 meter into 10.5 meter into 4.5 meter that can be used for this purpose. Okay. So this is all about the design of sedimentation tank. Now in my next video, I will discuss about another problem related to sedimentation tank, in which you have to calculate the detention period also. Thank you.